The aim of this video is to give you some advice on how to build appropriate tables and graphs to best display and work with your data that you're going to get for your practical coursework. We're going to talk through a generic pendulum experiment. None of the coursework or the actual experiments you're going to do, but it's a really good experiment to talk about because it shows how we can work with our data to obtain a straight line graph, how we're able to quantify uncertainties by taking repeat observations, and a number of other things as well. Our independent variable in this case is the length of our pendulum, which are going to vary. That's going to give us varying values for the time period of oscillation. That's our dependent variable. A bit more information is given on the right here. We're going to use this relationship. This is the relationship between time period and length, which is t equals 2 pi root L over g. It's kind of a clunky and ugly equation. So we're going to make life simpler for ourselves by squaring both sides. That gives us the equation t squared equals 4 pi squared times by L over g. If we plot a graph then of t squared, our dependent variable, on our y-axis, and L, our independent variable, on our x-axis, we'll end up with a straight line graph with a gradient of 4 pi squared over g. And what we can do from that is find a value for gravity. Take our gradient and find a value for the Earth's gravitational field. Because the time period is relatively short, what I'm going to do is I'm going to measure the time taken for 10 oscillations with a stopwatch, and then I'm going to divide the value on the stopwatch by 10 to get the time for one oscillation. The length of the pendulum I'm going to measure with a ruler. Now the first stage in setting up my Excel spreadsheet is to think about the instruments that I'm using. I need to, for full marks in my coursework, record the tolerances of those instruments. So, for example, the tolerance, or the smallest measurement that it's able to take, is 1 millimeter. My stopwatch, the smallest measurement that it's able to take, is 0.01 seconds. And I'm going to use those values, of that number of significant figures, to record my raw data to when I build my table. I can just record that using a text box. So there's a text box button. Once you've pressed the Insert tab at the top of Excel, insert text box and just record that data, and then it's there above the data table, and you're going to get the mark for that part of the exam. I now need to start building my table of results. I've got to decide here what are the things that I'm recording. So I'm recording the length of the pendulum, and for different values of length I'm recording the time taken for 10 oscillations. That's my raw data. I then process that to get the time period. So raw data is what I need to collect first. So with the length, here's my length. I've got two columns for my length. I've got a value column, which is just the length I measure, and then a plus or minus uncertainty column. And that's just my uncertainty in my measurement. It might be due to the tolerance of my instrument, but more likely with the pendulum experiment it's because it's quite difficult to establish the exact position of the centre of mass. So I'm going to have to be a little bit conservative. This is your judgment, but for this experiment anyway, I probably can't measure length to better than about a centimetre. I recorded the time for 10 oscillations, but then I repeated that 3 times in order to get more reliable results. So again, here I've recorded time for 10 oscillations, and then 1, 2, 3 different columns to record my 3 results. Now, to make this look neat, what I've done with my length and with my time for 10 oscillations headers is that I've merged those cells together, and that button can be found just here under the Home tab. So if you merge those cells, it makes things look a little bit nicer. The next thing I can do, just to make things even neater again, is I can press this little drop down on the alignment sign. And when I do that, what I end up with is this format cells. I might want to tick the wrap text column. That means that when you make your columns wider or thinner, the text will then go into 2, 3, 4 lines rather than being lost from the page. So if we have a look at that, I've wrapped my text, and something very strange has happened there underneath. So ignore this big blue stuff, but you can see the time for 10 oscillations is now squeezed up a bit. It's moved into 2 lines, but I can fit more data in laterally in my spreadsheet. Also, because I've got a lot of pride in my work and I want it to look neat and tidy for the examiners, I've made everything align centre of the box and centre vertically and also centre horizontally. So that's the headers for my raw data sorted. I now need to think about what I need to do in terms of working with the data. In particular, I need to go from the time for 10 oscillations for the time periods for each time I've observed the experiment. If we have a look at this next one, I've again got a big column at the top for time period. I've got 1, 2, 3, which relates to time periods for the third 3 set of results I've got. I then need to find an average and a value for uncertainty. Where I've taken repeat readings, my uncertainty is going to be the spread of my data, so the range divided by 2. I'm going to want to turn that into a percentage uncertainty, because actually with my graph I'm not plotting the time period, I'm plotting the time period squared. So I need to find the uncertainty in the time period squared, and it's a lot simpler to do that with percentage uncertainties than it is with the values. With this fourth column heading for t squared and the units there second squared, I'm going to need to find superscripts for the 2 in order to make it a squared rather than t2 over s2. So to do that, in my text bar at the top, I highlight the 2, I do the drop down on the font button. When I do that, a box comes up and I just tick superscript. Next, I want to start to make this look a little bit neat, so I'm going to start to do borders around my different columns, so it's nicely marked and delineated. So my length data is all the same stuff, so I'll put a big thick border over there. The border button again can be found in this home page and in the layout bit at the top underneath the text. So if I do that for length, time periods, I get a nice neat graph which looks something like that. And now I can start to input the data that I've collected. When I did the experiment, I took took readings for 10 different length values of my pendulum, ranging between 20 centimeters and 65 centimeters, and I went up with regular increments each time. So every 5 centimeters, so I changed length by 5 centimeters, took new measurements for the time period of oscillation. Now, I'm only happy to within 1 centimeter. That's what I decided my uncertainty was, but that's going to be the same whether it was a 20 centimeter long bit of string or a 65 centimeter long bit of string. So I just need to type into my column here 1 centimeter. Remember, all my units are in meters, so 20 centimeters, 0.2 meters, 1 centimeter, 0.01 meters. I can copy that by right-clicking on the square and pressing either Control-C on the keyboard or Copy in the little menu that comes up, and then I need to drag down the rest of the boxes that need to be filled, and I can paste. And if I press Paste Special, I've got 2 options that I'm going to use. This 1, 2, 3 is pasting the values. That's what I'm going to want on this occasion. Further down the line, we're going to have a look at this little FX box. That's pasting a formula. So if you've worked with data and you want to repeat the process for some new data, you can use that button. So once I've got my values for my length measurement, my independent variable, and the uncertainties copied down, I can start to put in my raw data. So this is the time taken for 10 oscillations for length of 0.2 meters, 0.25, 0.3. I can measure to the nearest hundredth of a second with my stopwatch, so I'm going to need to record my data to the nearest hundredth of a second. It's my raw data that I'm putting into the table here. Excel has a little bit of a problem in that when you record something like 10.10 seconds, 10.20, 10.40, 10.60, it knocks off the 0 at the end of that number. That means we're not giving that number to the same number of significant figures as the rest of the data. 4 significant figures there, 3 there, 4 there. We need to deal with this and make sure that everything is consistent. And to do that, we're going to use, again, Home tab at the top. These buttons here change the number of decimal places that you work to. So have a little play with those, and you should manage to get your data to the same number of significant figures. So if we look here, our 10.8 is turned to 10.80. This one I need to play around with still, make sure that's okay. Again, this data here isn't all to the same number of significant figures. It should be 0.20, 0.25, 0.30. So we need to play with these buttons to make sure everything is nice and consistent throughout. Once I have all of my raw data recorded, as I do at the moment here, I then need to start working with it. This is where we start to use the equations functions in Excel, which is really where the power of Excel lies. In order to do that, when you put your cursor onto a square or select a square, you want to type equals in. And when you type equals, that's a little note to Excel that it's then going to have to undertake some sort of function. Now, we recorded the time for 10 oscillations. We want to get the time for 1 oscillation, so obviously it's this time here divided by 10. So here I'm going to type into my spreadsheet equals D7, which is this cell number here, D7, or I could just write equals and click my mouse button, left click the mouse button on that square, and then I've done divided by 10, press enter. If I do that, it gives me an appropriate value. So here we find 8.78 divided by 10 is, surprise, surprise, 0.878. Because I've done it for that square, what I can now do is highlight all of the rest of the squares. Excel kind of works by saying, well, it's a function of 3 cells across. So what it's going to do is take every other cell and do the same sum to the cell 3 cells across, to there, for this one here, 1, 2, 3, it will do it for that value. So we can just copy and paste this one function and do 30 different calculations all at once. Because it's not actually the value though that I want to copy over, it's the function or the equation that I'm copying over. When I do my copy, I'm going to then want to go to paste and paste fx, so paste the formula. And if I do that, there we go, we've got all our answers, and that's taken just a matter of seconds. So just to summarise then, what I've now got is 3 different values for time period for one length value, and I've got that for 10 different lengths. My next job is to take those 3 different values and turn them into an average and an uncertainty by looking at the spread of the data and just finding the mean value. So first up, I need to find the mean value. To do that, I highlight the square that I'm going to put my data into. I go right equals, so again we're telling Excel we're going to use some sort of function, and then I type the word average and open a bracket. Once I've opened the bracket, I can then take my mouse, left click, and highlight the 3 squares that I'm trying to find the average of, and they'll come up automatically. So there we go, G7 to I7. Close the brackets, press enter, and the average will be input into that cell. I can then copy and paste, and again remember to use that paste fx function, and I've got the averages for all of my data, and again it's taken no time at all. To find the spread, I'm looking at the range of values, so the maximum value minus the minimum value, and then dividing it by 2. So in order to do that, this is a little bit more of a complicated function. Again, in my bar here, I type equals. The range is simply the maximum value divided by the min. And Excel is a function where you can highlight some data, it searches through it for the maximum value, and it searches through it for the minimum value. So what we do is equals, brackets, type in the word max, and then open brackets again and highlight the data that you're interested in finding the maximum value of, close the brackets, then press minus, type the word min, open brackets again, and again highlight the data that you're interested in, close those brackets, and if we pressed equals then that would give us the range. The spread is half of the range, so we need to take that and divide it by 2. So close all your brackets so everything's enclosed and just write divide by 2. You can just look at what we've got there and apply it to your own data set if you need. And again, copy and paste the formula all the way down, and all of a sudden we've got 10 different values for a time period, 10 different values for the uncertainty. Our next job is to find the percentage uncertainty. Our percentage uncertainty is basically asking what proportion of our total value, or an average value, is represented by our uncertainty or our spread. So we find that simply by, again, pressing the equals sign. We're going to put in the value of our spread. So you could just write equals, click on that square there, divided by the value of our data. So again, click on divided by, click on that square there, close your brackets. It's a percentage, so we need to times it by 100. And again, press enter and paste it all down, and now we've got values for our percentage uncertainties. One problem we do have is that we've got an inconsistency in the number of significant figures that we use, and if you look at your mark scheme, you need to be consistent with the number of significant figures. Now, we can't give our time period value to greater uncertainty or greater number of significant values than our method of measurement, so we can't give it better than to the nearest 0.01 seconds. So again, what we need to do is highlight all of our, play around with these buttons here so that we've got it to the same number of significant figures, or the same number of decimal places really, so 0.01 seconds, and then we can just leave it at that. And again, we need to do this with both our spread and our percentage uncertainties, just to keep everything consistent. My next job then is to find the time period. If you remember back to the equation, actually in order to get a straight line graph I need to plot the time period squared. So to find this value squares, I just press equals, J7, so highlight the square that I'm interested in. This little top hat symbol we can find on your keyboard just where the 6 button is. That means to the power of, so J7 squared, or J7 to the power of 2 equals, and we'll get whatever 0.9 squared is, 81. And then we'll work all the way down, copy down, and again we've got to deal with those number of significant figures. So play around with this button until you've got a consistent number. There we go. When you're dealing with your uncertainties, for t squared value, we've got to think about the rules for dealing with uncertainties. Now, cutting a long story short, if you are multiplying two values together, you are adding the percentage uncertainties. If you're dividing two values together, you're also adding the percentage uncertainties. So t squared is just t times by t. So the percentage uncertainty on t squared will be double the percentage uncertainty on t. So percentage uncertainty on t plus the percentage uncertainty on t. That's what I've put into my column there, and copy and paste all the way down, play around with a number of significant figures, and we've got some sensible values. My final stage in creating my data table is this. When I plot my graph, I'm not actually interested in my percentage uncertainties. I'm going to need to use the value of the uncertainty. So my next job is to find out what is 3.9% of 0.8. That's my value uncertainty. What is 0.99% of 1.02? In order to do that, I need to work out what formula that I'm going to need. If I was finding 10% of a value, I would do that value times by 0.1. If I'm finding 1%, it's that value times by 0.01. And if you think about it, what we're doing then is finding our value and multiplying it by the percentage uncertainty divided by 100. So again, just type that in to my formula bar. I've got to be careful where I put my brackets to make sure that the equation works sensibly. But if I do that, I come down and get all of those values. These red boxes here just highlighting the fact that I haven't yet dealt with the number of significant figures. So again, last check after I've finished all of my data, that's what I'm going to do. You'll notice that the values for my length measurements are now to the nearest millimetre. So we just need it's nice and consistent. We can then print off this data table and put that into our report.